Okay, hello, welcome to my channel. In this video, we want to find the integral from -1 to 1 of the square root of 2 minus x squared divided by 1 plus pi, and pi is raised to the power of tangent of x. Wow, look at this. Maybe you can pause the video and try this first. Right? Okay. Now, one of our previous videos, I did a video where I proved a property that tells us that when we have an integral over a symmetric interval, that is from a negative number to a negative number, maybe let me be writing it down, okay, an integral like this over a symmetric interval, maybe from negative a to a, all right, of an even function divided by 1 plus a number, in fact let's just say b, a positive number raised to an odd function, all right, maybe whatever the variable is, we are going to put the d of that variable here. When we have this, in fact, this right here is the same thing as the integral from 0 to a, just like half of that interval of just the even function. Isn't that very nice? We have a symmetric interval from -1 to 1. We have an even function at the top. This right here is an even function. It's an even function because if you evaluate this function when x is maybe negative of some number, it's going to be the same value as when x is just the positive version of that number. For example, when x is -1 and when x is 1, this function here stays the same. Why? Because when you square a negative number, it's the same thing as squaring the positive version of that number, isn't it? Good. And this right here is an odd function. Remember, a positive number. Pi is a positive number, of course, raised to an odd function. This right here is an odd function because if you evaluate this on a negative angle, it is the same thing as taking the negative of the evaluation of this function at the positive version of that angle. So it's an odd function. These are just from the definitions anyway. Okay, that's very nice. Let me clean this part so that we are going to look at this. All right, this is going to be the integral using this property from 0 to 1 of just the even function, which is the numerator in this case, 2x dx, just by using this property. Anyway, you can check this out in our last video. Okay, check it out over here, and maybe you learn the property and then you come back and then we continue. But for now, let me clean this part down and let's continue solving this. Okay, that's nice. So we have this integral, the square root of 2 minus x squared from 0 to 1, right? Okay, so I'm going to do a substitution here, which is motivated from the fact that we have a square root, and this term is a difference of two terms. We want to have just a single perfect square under the square root so that perfect square root will cancel out, right? The square, and then we're just going to have a single term. So how do we get there? Well, I'm going to do this using a trigonometric substitution, because I know that when we say 1 minus sine squared of an angle is cosine squared of the same angle. Cosine square is a perfect square under the square root sign. That will make sense a lot. So I'm going to start off by saying let's call x, right? Let me call it square root of 2 sine theta. And you wouldn't see why I'm saying that. So here we are going to differentiate this because we need a dx will be, well, this is just a constant multiple. The derivative of sine of theta will be cosine of theta, right? And then we can put the d theta over here. Good, because we are just differentiating this with respect to theta. So as you can see, this integral will now become the integral, well, from 0, right? Let me write it properly. From 0, well, we are doing a change of variable here, which means we will likely change the bounds of integration depending on what it will be with the new variable. So this is when x is 0. So when x is 0, we are going to have this to be 0, or maybe let me just put it here. When x is 0, what will theta be, right? If x here is 0, just like saying sine theta is equal to 0, well, theta should be 0 because sine of 0 will be 0. So theta is 0, which means this lower bound here is just 0. And then when x is 1, well, when x is 1, we're going to have 1 here. That will be 1 over square root of 2 is just sine of theta, right? We're trying to find out what theta will be. Well, sine of theta gives us 1 over root 2, which is the same thing as root 2 over 2. That means theta is in fact pi over 4 because sine of pi over 4 gives us that. So let me just write the smallest possible angle, all right, which is just pi over 4. Good. So in fact, let's just clean this since it was just a rough work. All right, so we have the square root of, well, 2 minus x squared. Well, what is x? X is called the square root of 2, right? In this case, we call x square root of 2 times the sine of theta. And then we are going to square that, right? And then we put the dx over here, where dx will be replaced by the square root of 2 times the cosine of theta d theta. Oh, that is very nice, isn't it? Okay, great. So let's see what we have. Well, I'll put the bounds of integration 0 to pi over 4. I think this 0 here is too big. Let me reduce it a little bit. Okay, pi over 4 of, now let's see, this is the square root of, we are going to square this term. Notice that the square of square root of 2 will just give us 2, right? 2 is common under the square root, so I'm going to put 2 here, and then I multiply it with, when we factor out 2, we're going to have 1 minus the square of sine theta, right? Very nice. And then we multiply this by the square root of 2. Maybe I can just put it out front, okay? And then we have the cosine of theta, and then you put the theta over here. Good. This is the square root of the product of 2 terms, the square root of 2 times 1 minus sine theta. You know that the square root of the product is the product of the square root. So I'm going to do this. I'm going to put this here at the square root of 2 here times the square root of this other term, right? Because the square root of the product is the product of the square roots. Good. So that tells us that this is going to be, well, the square root of 2 times the square root of 2 will just give us 2 outside. Then we're going to have the integral from 0 to pi over 4 of this. Note, 1 minus sine squared of an angle is cosine squared of that same angle, right? So we just have the square root of cosine squared of that angle, which is theta. We multiply it by the cosine of theta, and then we put the theta over here. Let's see what we have. We have the square root, we'll cancel out with the square. That means we're just going to have cosine inside here. And then multiplying cosine with cosine, in fact, everything in the inside will just remain cosine squared. So let me just put in here cosine squared of that angle theta, all right? Okay, that is nice. From here to that point. Good. Now to evaluate the square of cosine of an angle, the integral of that, we will need to rewrite it using its identity, okay? The trig identity for cosine squared of an angle. Let's see. When we have cosine squared of an angle, right, let me put it for you to note or to remember, it is the same thing as 1/2 of 1 plus cosine of 2 times that angle, right? We can do this using cosine of double angles, okay? When you find out the identity, it will be cosine squared minus sine squared of the angle theta in this case. Then you rewrite sine squared as 1 minus cosine squared, okay? You do some computations on that, you're going to see that cosine squared of theta is 1/2 of 1 plus cosine of 2 theta. That means in place of cosine squared of theta, I'm going to put this in. We're going to have 1/2 of, right? Inside, we're going to have 1 plus cosine of 2 theta. And then that's it. We put the theta over here. So maybe 1/2 can be pushed out of the integral sign. We're going to have 1/2 times 2. That will just be 1, right? So we have the integral from 0 to pi over 4 of 1 plus cosine of 2 theta. Oh, this is now the sum of 2 terms, which we can handle easily, isn't it? And it is very nice. So let's see what we have. So now the integral from 0 to pi over 4 of 1 over the theta variable, when we integrate that, we're just going to have theta from 0 to pi over 4, right? From 0 to pi over 4. This is theta. And then we add it with, well, the integral of cosine of 2 theta. The integral of cosine is positive sign, right? So you first of all put in positive sign. Sign of what? Well, we are going to maintain the same angle. But here with a little different, because this right here is 2 theta. Well, if we are differentiating, we multiply by the coefficient of theta. But since we are integrating, we will divide it by the coefficient of theta. Very nice, right? And don't forget, from 0 to pi over 4. We are done integrating. Maybe you should add an arbitrary constant, right? No. This is called a definite integral. When we do it, we do not put in an arbitrary constant because the result is just going to be a number. Okay, so let's substitute the bounds of integration and see how we end the video. Okay, the is very nice. So this is theta. We evaluate theta from pi over 4 to 0. That is going to be pi over 4 minus, when theta is 0, it is just 0, right? In fact, right there we just have pi over 4. We add it with, well, I'm going to put 1/2 out front. Then we're going to have sine of 2 times theta. Well, when theta is pi over 4, we have 2 times pi over 4, right? Okay, we say minus sine of 2 times 0. Well, when theta is just 0, okay, that is the first, the upper bound minus when we substitute this lower. So we're going to have pi over 4 right here, right? Plus, well, 1/2 of, let me just put it out front. Hope it's not too down. Okay, sine of 2 times pi over 4. This is pi over 2. Okay, sine of pi over 2 is like saying sine of 90, which is just 1, right? Minus 2 times 0 is 0. Sine of 0, in fact, is 0. So, in fact, here we just have 1. So, altogether, this right here will become pi over 4. Let me just do this. Okay, pi over 4 plus 1/2. That is 1/2 plus pi over 4. And this right here is a nice place. Okay, because this pi is an irrational number, I don't want to add things a lot more. Okay, this is very nice. This integral gives us that, and in fact this was the original question. It's just equals to 1/2 plus pi over 4. So what we really did here was to evaluate the integral of 2 minus x squared from 0 to 1. Okay, that's very nice. Alright, thanks for watching, and I hope you enjoyed this video. It is not as difficult as it seemed, right? Thanks to that property. So you check out that video, and see you in our next video.